Right. Hey everyone, this is the 8th KMS meeting for March 1st, 2022. I think Anish, you had wanted to sort of talk about maybe your learnings and stuff from some POC work, and then we can kind of go from there.
Yeah, so after the last call, what I started doing was I started making some of the changes on my branch. So I got as far as creating a new API, the Proto API for V2 Alpha 1, adding the new UID field, and then the KEK version. And then I am actually in the process of using the Proto serializer so that we can use that for storing. I got a little sidetracked because I had to finish up another thing and then I had a presentation yesterday. But hopefully I'll be done with that by today or tomorrow. And then I have some of the changes already in a branch, so I'll share that branch with the group. And then simultaneously, I'm making changes on the Azure KMS provider. So on the KMS provider side, I'm just trying to do a very basic where I'm generating the key, similar to how we're doing the deck right now, and then trying to use it for certain number of operations before regenerating the key in memory. So I'm doing that just to mimic what we talked about, right? And then right now, how I'm thinking is I generate the key, use it for 1,000 encrypt operations. And then once I hit 1,000, then I basically regenerate the key. And then I think that part is where we would end up replacing with some library like Pink, where there's a key set, or we could add that in the reference implementation on how we decide to go. But I'm working on that. And then I'm going to string those two together and then test it out this week. And then I'll have the branches shared on the Slack thread, and then we can just go from there.
Okay, so just to make sure I understood, the Azure KMS changes are basically the starting points of a key hierarchy implementation within the KMS plugin itself. And so presumably you're generating that in-memory key, encrypting it with the real KMS key, I guess, and then returning it as part of your response to the Kubernetes API. And in the next iteration of the Proto API, it would be like in the version field or something, somehow. It would be okay.
Yeah, and then I think this is probably a good first step so that we just validate this works. And then the second thing is obviously like the migration, right? Like I'm not focusing on the storage migration part of it yet. But once we have this and we say, yes, this is the approach that we want to take, then we can actually go and think about how we want to do the migration in this part. And then we can make changes in my branch, or like we can work on it together.
When you say migration, are you referring to the act of migrating from an older encryption format to a newer one, or are you talking about like in-place rotation or something else?
So actually, that's a good thing, right? Like both of it. So first one, when I talk about migration, it's the storage migration, from changing it from the old format to how we're doing it the new way. So that's the first one. And then once we have this in place, then we also need to see what we want to do with rotation. Is that something that we want to do without any user intervention? Or because I think we talked about having another RPC request which says like from KMS to API server, maybe to say that, hey, look, keys are rotated. So if you have anything old, like call me with all the old keys, and then we can do the rotation now. So I think that's the second piece of it. But when I was talking about it, I was talking about the storage migration, basically.
Okay. So I guess on storage migration, I would ask, since we're implementing a new API, a new Proto API, right? Wouldn't we be able to sort of cheat on that one and just say that you just configure the KMS plugin twice?
With the newer version?
Yeah, so like, you start off by having it as a read key, redeploy, turn it into a write key, redeploy, do storage migration, and it'll just be, everything will be just forced rewritten to the new version, right? So that, I'm thinking about migration in the sense of like, N releases from now, let's say all this stuff is stable and ready to go, and people are like, cool, I'm going to upgrade from KMS version 1, beta 1 to version 2 stable, right? And like, that's just a one-time event, right? It doesn't have to be automated or beautiful. It just has to be possible and safe to do, and needs to support rollback, which I think all the existing mechanisms basically do. So I don't know if we had to actually do anything too fancy there.
Okay. It actually makes sense. Yeah, we would then ask them to configure both of it. That actually makes sense. And then encrypt it with the new one, and then decrypt would work with both, and then on the round trip re-encrypt everything is with the first.
Yeah. So there will be some pain one time. Sure. Like, yeah, but it's new clusters. You just don't worry about it. You just start with a new API, and old clusters you have to do a one-time migration. Okay. Is there anything like you wanted to share your screen and share or anything like that? I did make you co-host, so you can do whatever you want.
Yeah, no, I'm not there yet.
All right, no, it's totally cool. I just wanted to make sure. Here, I'm just gonna make everybody co-host because it's easier. All right. Was there anything specific we want to continue talking about in regards to like just the overall improvement effort? Because Anish, you're working on basically the new API and the reference implementation kind of vaguely together, right? Like, because you're like, I'm going to glue them together and like see if it actually makes sense and works, right? So you're doing exploration effort, which is appreciated and really helpful. Was there anything specific folks want to talk about in regards to the doc? What is that called? The cap.
I think one thing outstanding in performance, I mean, it was grouped in performance, but the option to choose encryption protocol, I think we talked very briefly about it, but that's a separate work stream. So I was wondering if that's something that we still want to do, like default it, or do we allow the user to choose which one they want?
Share my screen. Hold on, that's really nice. Just make a. Nope, this is the wrong doc. Sorry.
I can share the link for the plan.
I will. I'm almost there. I'm just like going through the places I know I have the link stored. All right, cool. So I have. So, which section was this in?
Oh, this is actually the other one. The one we have is the different doc side that is on the chat. This is the old one that was added.
Okay.
Yeah, and then here, if you scroll down, so I think with the hierarchy, we are talking about cache warm-up, deck generation, and all those. But yeah, right above observability, there is a section called choosing, option to choose encryption protocol. And then hot reload of encryption config. So like these two are points I think we haven't talked about. And I think we can just discuss that. If it's not something we want to do, that's fine, but I think we just added it there.
Okay, so if we I think hot reload is a little bit easier to talk about, mostly in the sense of I was kind of leaning towards we would not need the hot reload stuff anymore if we just gave the KMS plugin implementation / API the rotation capability, because that is why you want hot reload is to be able to do rotation without API server restarts. But if you can already do that, I'm not sure if the hot reload actually has any value, because you're never changing the config. You're just, it's happening at the RPC layer of the KMS provider, and it's not actually happening at the YAML file.
But there are also two layers of rotation, right? Like one is basically like the deck that the deck you're generating in the key encryption key you're generating in memory gets changed like after every certain number of operations. And then the second rotation that can happen is the one that you actually store in the external secret store. And at least from what I've seen in all the providers today, like KMS providers, when they get deployed, they are deployed with a certain key KMS entry and then a version. So they're like pinned to a particular version. And if the KEK in key vault gets rotated, then they basically redeploy another pod with pinning it to the newer version so that it can be fixed to that, right? So that still needs user action to be done for that rotation. And then that could mean that they have to update their encryption config.
That is a fair point. Do we want
And I think also with this, there is one problem, right? Like the thing is today, when we update the encryption config and restart API server, if something is wrong with the encryption config, then we basically break, the API server fails to start, right? Like it says health check failed and all that. And I think that is interesting with the hot reload. Like if it's watching on that file and it automatically picks it up, should it fail when the encryption config is invalid, or should it just continue to work with what it has now and then just generate an error, a warning saying like, hey, look, I have not reloaded because the new config you have is incorrect. Like, I think there's also that associated with this.
Yeah, so certainly I don't think we would want it to be possible for a running API server to immediately go into a failing state just because you have an error in your config. I mean, I could see arguments saying that the encryption configuration is important and sensitive, and you should honor it all the time, like explicitly, because that's like how you encrypt data at rest. But at the same time, I don't think anybody wants their API server to just stop working because they have a typo somewhere. But yeah, so okay, so the use case we're wanting to address here is rotation that occurs at the key vault level of a cloud key vault. I guess I would ask, is the existing procedure for that, which involves, like, so the existing procedure is you add new read keys, restart, swap them to write keys, restart, do storage migration, and you're done. Or sorry, do storage migration, remove the old KMS, restart. And that's the full process, you know, across your entire infrastructure. That's really painful. Like just even saying it out loud just makes me sad. So with hot reload, it would be add, update the file across the API servers to add them as read keys. Somehow wait to know that the change has been observed. Somehow you have to know that your API server's caught up to that read. Then make it a write key. You don't have to wait for the writes to be observed yet, because you know that there was a read key. Then you can drop all the read keys, the old ones. You also don't have to wait for that to be observed-ish. As long as you're willing to say you're not going to do these rotations quickly back to back, because you're going to do them quickly back to back, and you also need a barrier at the end of that to say that you observed that state.
Right.
So that's certainly much easier. granted, it's in some ways a lot scarier because you're changing the encryption configuration of the server live, and you're really hoping you don't do it wrong. Yeah, I guess I would ask, is there some ideas for how we could do this better? Like, is there not a way to let, I guess I would ask, is there a way that we can think of that could be done over the RPC API, or like just more dynamically through the KMS plugin, let it manage this itself somehow instead of it being driven through file changes on disk? Maybe that's fine.
I think, like, I mean, the file changes still might be required, but again, RPC would probably be a good way to do it dynamically, right? Like, and then it's almost like when the new provider pod starts up, it just makes an RPC call to say, hey, like, I am available and this is my key. And then the API server then goes through the encryption config and says, out of these providers, which is the first one? So like, it's like, oh, this one is the one that I need to encrypt everything with. So let me go and rotate everything that I have, so I encrypt with this.
Well, so there's two things in my head, right? One is I'm trying to think of, is there a way that we can sort of get out of the business of using like the ordering of basically the key set in that file as the rotation mechanism? Like, it works and is okay, but it's not exactly the most flexible and fun thing to play with. But the other thing is, like, when I think of these file-based mechanisms, even with hot reloading, when I see clusters that are spun up with like kubeadm in those environments, and like also like OpenShift, all these self-hosted environments, changing files on disk is really hard because there are a bunch of static pods and a bunch of crazy config, and basically like changing files on disk is like upgrade, right? And it's just not. It might be trivial in an environment where the API server is orchestrated by a higher entity, like a cloud VM orchestrator thing. It's like super annoying and super hard when the orchestrator of your Kubernetes cluster is the API server itself. So like it's basically like, oh, you want to change this file? You better never ever do it wrong, because if you do, you'll break yourself, and then you won't be able to fix yourself because you broke yourself.
I think CSI does this in a nice way, right? Like, but again, it's at least for CSI, it's not system critical, but they do dynamic plugin registration. So when a new CSI driver comes in, it goes and dynamically registers itself with kubelet to say, hey, look, I'm a new driver, and then I'm listening on this socket. And then if anyone references me, then just do this. We could do something similar for the API server and KMS, where when the provider comes up, it dynamically registers and says like, hey, I'm this particular KMS plugin. I'm listening on this Unix domain socket. And next time when you have to encrypt, just make this call to me, and then that would work. So then when this dynamic registration happens, like all the API server basically has a map of all the entries. So when it has to decrypt, it loops through all of it and then decrypts it. I think the key is we need to decide how does it decide which one to call for encrypt? Like, is it like a rank basis? How does it happen? Like, that's one area that we need to figure out. And then based on the health check that it's doing, like if the health check fails over like a period of time, we can have a definition on what that period is. If the health check fails over that period, then basically API server can remove that plugin from the map. Like, it doesn't have to call it going forward, because there is no mechanism where a dying KMS provider will say like, deregister me. So we can just rely on health check for that purposes. But if we do switch to a dynamic registration, then we can completely rely on RPC and then not have this ordering in encryption config at all.
So I'm not familiar with CSI enough. What's like the mechanism for knowing that like a trusted actor is the one that's saying that I can be a CSI driver? just trust me, I'm here? Is it just by virtue of the fact that it can create a Unix domain socket?
So it's a mixture of that. So there is this component in CSI called node driver registrar. It's a sidecar container from the CSI team. So when you actually implement a CSI driver, you add that sidecar in your driver. And when your driver pod starts up, node driver registrar talks to your CSI driver to get metadata on what the driver name is, what version it's running. And then there is also a corresponding CSI driver Kubernetes object. So the node driver registrar, when it gets this information, there is a well-known socket path on kubelet. So there is a file system path, var, lib, kubelet, plugin registry, something like that. So you mount that volume, and then in that particular volume, the node driver registrar adds information about this driver. So I think the file system is the trust, who mounts it and then who adds to it. And once that is added, kubelet basically has a file system watcher. So it says, hey, I see this new driver that's been added, which means if anyone references this driver, I know how to make an RPC call to this particular driver. And then in terms of verification, I think it also goes and verifies that there is a CSI driver object for this with this particular name. And then it just says whatever information I have is also valid based on the Kubernetes object. And then it says everything is good, and then it just trusts it.
Okay. I'm trying to think through. Does such a mechanism sound like reasonable for the API server? Like I'm trying to think. Like, it's not meant to be like a critical question. It's just I'm just trying to reason my way through the differences of like what does it mean to register things to a kubelet versus to register things to like an API server. Certainly you can be running an API server on a kubelet. It's a control plane kubelet, so certainly that seems fine. And that's actually the case that I'm trying to reason through, right, which is kubeadm and those styles of environments. It's just a much easier problem when you have a one order orchestrator above you to help you do the rollouts. So
is there some way we can tie this with RBAC permissions or something? So at least with today's model, it's not possible, right? Today, I think we consider KMS as system critical, which means if KMS is not running, I think we start health check after 40 seconds. So after 40 seconds, if KMS is not running, API server keeps restarting. So if we do decide we want to do dynamic, then KMS is no longer system critical. It's just more like an add-on that gets injected into the path for the API server request. But is there a way we can do this with RBAC, like RBAC permissions, so we can scope it down to who has permissions to register dynamically?
Yeah, I guess the failure mode of CSI is much less benign in this. I mean, it's still really bad. Like your apps could stop working, which is kind of the whole point. So depending on who you ask, that's super bad. I guess I would do kind of vary, right? Like if you register a KMS provider and it's working fine, but then for some reason it stops working fine, like cluster is no longer functional, right? Because whatever data was encrypted with that KMS provider is just gone until you fix it. Like it's not even just inaccessible. It just is random noise, right? It's useless to anyone but that KMS provider. So like, I feel like it would be a hard sell to say that there's like a Kubernetes level object that represents a KMS provider.
I feel like this is why it's a file on the file system.
Right.
Because the thought is like, that is like Uber permission, right? Like if you can get on the host, you could do anything.
Right.
It's almost like the static pod, right? Where it's a very highly privileged component. And if it dies, like if you get hacked, then the whole cluster you would be able to hack anything else.
Yeah, so I guess the question I'm trying to reason my way through is, if we continue with the file-based mechanism, how do we support environments that are self-hosted in being able to do this kind of work, right? Or is that not our problem? Maybe it's not. I mean,
and then don't forget there's also like the multi-master stuff. Like, oh, so many files, how do we keep them in sync? Like,
right.
Yeah.
Yeah, well, I mean, yeah, so that makes the problem even worse. But you know, today I think we hand wave this and say that, well, you better make sure your API server configuration is exactly the same across all your API servers, because if it's not, you're just in some undefined state. Like nothing good will come out of it. Which I mean, I guess is fine. I'm just trying to think of like if we can do anything here to make this more practical. Certainly, hot reload does seem valuable, and I think will make at least some things easier. Maybe not. I'm still trying to debate in my head what the semantics of a failed configuration load is. I think it has to be just keep using the old one, because like don't die. The API server should just not die.
well, also like, how is this different from like when you upgrade a Kubernetes cluster? Like when you upgrade a Kubernetes cluster, the control plane, like the master nodes are upgrading at different times, and a lot of files on the file system get updated, right? Like the
Right.
configs. So we're not doing anything different here.
So the difference in my mind is, so one, I agree with you that it is basically an upgrade. The difference is a general upgrade, like, you know, I'm thinking about self-hosted environments, is that going back and forth is relatively easy. Like it is possible because you're not using math to make impossible scenarios occur, which is what encryption is. But the other thing is, I don't want to have to tell someone like a kubeADM user that the way you rotate your encryption is by doing an upgrade, because that sounds scary and is kind of scary. But maybe that's just sort of the nature of the kubeADM workflow, that like maybe you would do an upgrade like from version A to still version A, but like somehow pass in new encryption configuration. So like it just kind of changes the one file on disk and nothing else actually changes. I don't actually know how kubeADM upgrades exactly work.
Well, another thing is like, I mean, again, today, like the manual process, right, is we need to make sure both of them are there at the same time for a while until we know like the old one is safely removable, right? So if we're doing this in an automated way, like that is still very much the case, right? Like I think as an operator, knowing the old one and the new one are running in parallel, and then I can easily access the old stuff while I introduce the new one, that's comforting. So I think knowing that if we can provide a good way, like for example, like status or something, to let the operator know, okay, now you can safely remove the old one from the configuration, it would be helpful. And maybe this is something we can automate, I'm not sure. But
Yeah,
we
so
can't get away from running them in parallel though, right? Like that will always be the case.
Yeah, so you have to run them in parallel. You need a way to observe externally from the API server what it has observed as its configuration. And you have to, after you've done that, you have to be able to run a storage migration. You need all of those steps to know that you can safely remove things. And you need a guarantee that the storage migration cannot be confused by any key hierarchy mechanism going on. Now, that one I think is pretty easy if it's literally separate levels, because that's very easily detectable within the way stuff is implemented today. Yeah, so I'm trying to remember, I vaguely remember like there was like the API server ID kept thing where each API server had like a unique identifier. Did that ever go anywhere? Like, do we have like the notion of like an API server in the Kubernetes API that represents each instance? Like, do we have a place where one could actually put status of an API server, particular API server?
I don't recall.
So that essentially gives like a object where you can query and see like fields related to the API server, like, or
Yeah, it's something, right? Like you know, we're talking about. I want to know like what API server A understands as its configuration. You know, I'm backing up that conversation to be like, well, what are the API servers available? First of all, so like we even have like, right, like, do we have a way to query that? Because it's not like part of like the Kubernetes surface, right, that you can normally address, right? You can't normally just do like, for example, when you do kubectl get nodes on the cloud providers, usually the nodes don't contain the API server nodes. They only contain the workload nodes on purpose, right? And I don't expect that to change. So how do you know how many API servers that you have and what state that they've reached? Right? Like I guess in a sense, I'm trying to be very sympathetic to the individual that has to orchestrate this. And if we're willing to accept it's a file-based API and thus will always require some level of fancy cluster-specific orchestration based on however you manage files on disk for your API server, even if we're willing to accept that and that has hot reloading and all that, the rest of it doesn't necessarily have to be painful and awful, right? Like there could be some way to observe this.
yeah, I think that I mean you talked about kubeadm, right? Like how on a self-hosted cluster, and I think also the other problem is for different cloud providers, they have to implement this in a different way. Like each one who supports KMS, and they have to implement rotation in their own way. And then also it's not deterministic. Like you have both the providers running simultaneously, but you need to make a decision on when you think all the rotation is complete. So like periodically you go and rotate every namespace, and then when you're completely certain based on some data that you are maintaining that you have rotated secrets in every namespace, then you go and update the encryption config. But yeah, there is no Kubernetes way which says like, hey, the rotation is done.
Right. So two things, right? So if you can validate that you know that a particular level has been observed by all of your API servers, so you have a store that's in your cloud somewhere that's like, these are the API servers that belong to this cluster, and you can validate that they reached a particular config. I believe the storage migrator and API discovery has enough information with the API storage version hash thingy to like, I think it has enough information in there. I forget exactly how all that's computed, that if you told it that you wanted to do a storage migration at a particular point in time after that has occurred, and that went off and did its thing and came back to you, I think that would be enough. Like I think, because that's kind of the point of the storage version migrator. So like yeah, basically I'm trying to get this problem down to the orchestrator is responsible for updating the file. We're responsible for making it so that it's clear through some nice Kubernetes mechanism the state of the system after that's been done. So that way the rest of the pieces of the system can just be generically automated across all the cloud providers and KubeADM and everybody else. You just have to build a one mechanism for your infrastructure. This is how you update files. And this is how you know what cluster API servers exist in the first place, so you can actually go update all the files at the same time.
Yeah.
If we want, I can take an action item to try to see if I could find whatever happened to the API server ID thing, or see if there's any KEPs or things in flight from API machinery in regards to like API server specific configuration or at least observability of that configuration, maybe through the Kubernetes API or some other standard-ish mechanism.
Yeah, I found something about API server identity. I shared that on the chat, but yeah, we can look at that. Amazing.
I think that ensures like all the API servers are have the same state, but you still don't know when all the rotations are done, right? Like,
Yeah, no, that's why I'm talking about the storage version hash and the storage migrator, right? That's why that was all built, to be able to assert that when you asked for a storage migration for a particular resource at a particular time, when the status of that request says it's complete,
okay,
it actually happened.
I see.
No. I forget how far they got along that route. Like, I know that in API discovery, there is a storage version hash that's opaque and stuff and is used by the storage version migrator, but I can also investigate that if folks want. Like, so I can look at the identity stuff to basically see if
How is that we don't have this for like upgrades?
we don't
I
have
would think this is useful for upgrades as well, right?
what is useful.
The like what you're typing, like,
The storage version migrated.
yeah.
It's still an optional component that you don't have to use. It's Kubernetes, everybody gets to do whatever they want.
Right, but like I can see this is also super useful for in an upgrade scenario, right? Like,
Yeah, you're supposed to run it.
yeah. Like
Yeah.
very often during an upgrade, like you after the upgrade, you test like a new API and you're like, wait, this doesn't work. And it's because like something got stuck in the middle and you have to like go back and restart the API server. It's like having something like this is like, okay, you just know it will work, right? Like, kind of interesting. You sure Kubernetes is in production? Just kidding.
Maybe it shouldn't be, but it is.
Very debatable. But yeah, that's
Okay, so we have some things we can investigate there. Okay. But the general gist I got was folks think that this is valuable. That we should pursue this. This would make migration, make rotation and migration easier. Probably is not that hard to do as long as you're careful with your edge cases, and yeah, so I think that's probably fine. But I have talked about who's got opinions on this.
sorry, what was the question?
Who has opinions on should encryption protocols be configurable?
I have no opinion. I just want this to be an optional thing so we don't default to what we have today. Because there are a lot of very opinionated people out there. So as long as we have a hook for them to specify it, everybody's happy.
But
Right?
what do we mean by specify? Do we mean to give them an interface that it's their problem to implement, or just picking the
Make
right
it configurable. Right?
But even then, right? Like, so today you could say configurability today in the existing world, configurability would be how is the data encryption key sorry, yeah. How is the data encryption key used when encryption is done? That's what would be configurable, right? I'm a little bit wary of making this configurable because it pins our choices, right? It means that, say we tell you that you can use AES-CBC or AES-GCM, that basically how the internals of the envelope encryption work today, which are an implementation detail of the system, are effectively codified. You can't change them. Okay. Right? Like, does that make sense? Like we're starting to say that those details are specifically exactly how the system is basically always going to work. Right? Because otherwise the config wouldn't make any sense.
But today it's like there's no way to change it.
Right. Today, there's no way to influence the fact that CBC is used for the act of encrypting a single set of bytes representing one object at one instance with one particular data encryption key. That's what it sort of it represents, right? And we certainly want to use GCM over CBC because it's an authenticated format, and because it's only used once, it can never be vulnerable to any of the issues that GCM has. Yeah, I'm trying to think through this as a like, if you truly care about this, I'm not sure if this just being able to change this particular thing is what you want, right? Like the whole idea of an in-process data encryption key generated by a Go system is a little wonky, right? Like wouldn't you actually just want your KMS to directly encrypt the data itself? Like if you truly care. Does the question I'm asking make sense? Like if you're really opinionated and you really care about this?
Yeah.
So would this actually solve any problem? Would it actually give anyone a knob that they cared about?
I think it will give them a way to, I mean, whatever we set as default is one thing, which can be something that is debatable within the community, right? And then the other thing is, if somebody wants something that is not the default, how would they do it? Like, what's our guidance here?
Well, no, what I'm saying is that this configuration is really basically saying that that we want to do envelope encryption using this data encryption key scheme, right? And we're going to let you tweak a tiny little bit of it. I'm mostly saying I'm not sure that satisfies anyone that would actually care, right? Like if I truly wanted my PKCL and hardware-based KMS to be the one doing the encryption, I would just want you to pass the actual bytes of the object, like the Kubernetes object, to it, let it encrypt it, hand you back the encrypted blob, and that's how the encryption works. There's no in-memory keys, there's none of this gobbledygook going on, right? Like my KMS is actually doing all the encryption, right? And you're not involved in this arbitrary layering and stuff, right? Like that's what I would actually want if I wanted to have high-level control on this, right? And then I would use whatever encryption scheme was sound to me, whether it's like secret box or AES-GCM or whatever, right? Implemented in hardware on my KMS, right? Like if you actually care, that's what I would feel like you would ask for. Not
right, but that's like outside of Kubernetes, right? And
no, I mean, Kubernetes would have to directly support it, is what I'm saying, is what's missing, right? Is that like, if you're saying that there's people that have opinions and want to change this, well, first of all, one, I don't think I've actually seen them, I haven't had anyone ask me for this config. I had a lot of random asks for random things, but not this one. But like, I don't know if this solves a problem that people actually have, right? Like if it's AES GCM and that's what we just say it is, and I do think we should encode that decision into the storage so that it's observable in the storage if we decide to change our mind. Because today it's not, right? It's just implicit. So I think that's wrong. I think it should be explicit and part of the schema, right? Just as a thing. Right? But I'm less convinced that we should give people a knob that I'm not really sure what it changes.
Yeah, I think Anish pasted some issues.
I can
And
Yeah, so in the previous KMS proposal doc, I mean, that was done like I think 2-3 years back. Like these two were the reasons for crypto agility, right? Like letting the user decide which protocol they want to use.
Yeah, I think the particular problem why people are so annoyed by the current decision is that we have AES CBC, which is for itself a little bit problematic, and also is not authenticated. So if someone would flip a couple of bytes or bits, it wouldn't you wouldn't register that. So it could actually be decrypted and make sense or not, but obviously it would be better if it wouldn't make sense, but you could kind of malform the ciphertext, and this is why a lot of people have an issue with that. So yeah, so it's not possible. Yeah, I don't think that anyone would have big issues with AES GCM. Maybe people would come up with wishes for, I don't know, details. So this is possible. Maybe they say we want a 128-bit key or 256. So if you want to I don't know what, play with the hash, right? But I think CBC was a particular thing, and for countries like Russia and China, I would just assume that they give them access to whatever they have. I don't know if so I once read the blog post years ago where I heard that the Russian state, so I don't know if it's still true, but I just read that they just have a key for it, right? So we create an additional key with whom, or they have an admin user account with how they can just access it. I don't think that they kind of want to have weak encryption, that they can kind of brute force it, because even on weaker ciphers, it's up a lot of resources.
So I think the last comment there was basically for areas where the government requires access to this, you don't really give them access to the encryption. You just give them admin access to the Kubernetes API, and if they wanted, they do it. Like they just skip all the encryption, right? They just ask for the data if they want it, which is fine. I mean, there's no big deal. Yeah, I guess. Yeah, like, so I remember, Alex opening this PR, this was 2 years ago, right? And I was like, yeah, that's cool. Let's, if you don't like it, let's just make it GCM, right? That was my response. I was like, I don't want to config. Like, there's actually no reason to use CBC. This is like the wrong choice. It should just have been GCM. Like, there isn't actually any meaningful reason. But if there's no meaningful reason to ever use CBC, then just use GCM and be done with it. What's the other choice? You can't use secret
backward compatibility.
Well, we're not going to be backwards compatible, right? Because we're doing a full revision of the storage anyway, right? So just by definition, not backwards compatible. You have to do a migration, right? So I don't think that's an issue here. Secret box basically fails the canonical check of, can you use it in the government? No, you can't. So like, I don't even know what the point of offering it would be. Even though it's probably better than all of these.
So what was the reason for wanting to keep CBC?
There wasn't any.
Okay.
The only reason this PR didn't go through is because Mike was like, hey, if we're gonna change everything, let's just change everything. I was like, yeah, that's probably a good idea. So we just stopped, right? And then we never got back to it. And 2 years later.
Sounds familiar.
Yeah. Right, but it was basically like, yeah, we should change this, but while we're at it, we should also like change all of it because
we-
it's so bad.
Can we add this to SIGOT meeting? Like, let's talk about this.
Okay, yeah, that's actually fair. That's fair. Yeah, let's
I'm
just,
totally fine either way, but I mean, that would certainly make implementation easier.
so that's
I just
tomorrow.
assumed there would be people who want the like today's behavior.
So maybe I've jumped on the hype train, but I'm a big fan of WireGuard and the fuck you to your crypto agility. Like I'm on a recorded call. I shouldn't say that, but so like
It's there forever now.
Yeah, I just nobody looks for these. Nobody even watches the SIGOT ones. I really doubt anyone watches this one. But yes, yeah, I don't know. I'm just like, I don't know, just put it somewhere where you can find it and change it if you need to change it.
I mean, we've definitely heard people asking for GCM support. That's why it's in the doc. But I did not hear anybody asking for CBC, but that's also because it's already there. That's the default.
Well, the advantage of GCM is that, so when you do CBC in production, actually what you would do is, so you not only use it for encrypting, but you also need to hash the ciphertext and send the hash alongside, so you can verify that nothing was changed. And this is, and you could do a lot of things wrong. So people like, for example, hashing the plain text instead of the ciphertext and stuff like this. And it gets, people can shoot themselves quickly into the foot when they try to do it. So this is what the beauty of GCM. And in addition to that, GCM is also more performant on hardware and software implementation. So it's just clearly the better algorithm. I can't imagine why people would like to stay on a CBC that's not authenticated.
Yeah, like I'm pretty sure this is just a typo. Like we just made a typo when we implemented the envelope encryption. And instead of typing in CBC, GCM, we typed in CBC because it's just
That's
literally
a
one.
very big typo.
Boy, but it's literally one line, Rita. Like a single line which has no test, by the way, right? Because it's all punched out. It's all punched out in the test as like input that you can just change.
Well then, yeah, let's just definitely get some consensus here.
Okay. Yeah, I mean, I still think, we want to make sure that it's encoded within our storage format. So that way, if we decide to change our mind, it's not like a catastrophic decision. It's like an obvious and observable decision. Also, this is literally the only item on the agenda for tomorrow. So that's good, I guess. We added it before the rough time where I tell people you can't add any more stuff. I'm gonna make you wait 2 weeks. All right, we got like a minute left.
One thing, so I don't think it's, so definitely we should be able to quickly change the cipher if don't know, someone is able to find a weakness in it and we need to exchange it, right? So it's definitely worth to have it in a place where it wouldn't take us a week or something to change it, but more like in the frame of 1-2 days. So it should not be, we don't need to invest time until people complain to it configurable, but it should be easily exchangeable in code, right? That we kind of patch version.
Yeah.
And in the last 2 minutes, so with regards to the reference implementation, so I started to look into the Pixie 11, which does not have so broad support in Go, but there's actually one wrapper around some C libraries. So I just started today with it because also I was busy. I got some epics that need to be ready for the next release and some bugs, but I started with it. And it's super messy, but I hope that I can come up with the mixture of Think and the Pixie 11 implementation by the end of the week.
The wrapper that you found, is that the one that Let's Encrypt uses?
Yes.
Okay, I just wanted to make sure because that's the one that I know of. I mean, if it's good enough for them, it's good enough for us.
Oh yeah, yeah. I checked. There's several bigger projects who use this library. So if they trust it, maybe we can trust it too. But yeah, it doesn't feel like first class support yet for the Go language. So
Yeah, I guess as a somewhere we should record the need to review the wrapper, right? Like just actually look at it, see what it does, and make sure it's vaguely sound C code / Go code.
yeah, so I think we then also forced to use Seago and nah.
Yeah, which is okay. I guess for the reference implementation, we would just want to make sure that you can use the library parts of it without needing Seago, right? So it needs to be separated out with no tags and stuff so that it's possible to use the library without Seago.
Yeah.
But that shouldn't be too bad, right?
Okay, so we'll just post something in a chat once I have something that is showable. I mean, I push it to repository, so you can see already something right now, but I don't see any benefit right now in it. I would just post it in a chat and present something in the next KMS meeting.
Awesome, sounds good. Well, take care.
Bye.
Bye.